Right. Good evening, ladies and gentlemen, doctors. And first of all, I would like to thank the Sri Lanka Dental Association and also Dr. Suresh, yes, for inviting me today. It's a great pleasure to be here to share some of the research done and some of the experience. So that is pretty much matching with the professional doctors, and I'm a scientist by profession. So nanotechnology and health. Now it's a hot topic and it's on everybody's lips today. Even the young generation to the the old generation, nanotechnology and the bio-nanotechnology sometimes. So what is nanotechnology? Why is it important to us as a country and as well as a scientist or as a maybe in the health sector? So that is what I am going to share some of the experiences, right? And also how it affects to our health, and basically is it good or bad? It's like the two sides of the coin. So basically, nanotechnology, when we talk about the nanotechnology, so we come from the kilometer, meter, and also micrometer, nanometer, and angstrom. We all know that doing A-level, advanced level science, we deal with molecules and atoms all the time, even in our university life, and sometimes the protein and enzymes. So that's what we do, and they all are in angstrom level. A little bit smaller, that is the smallest level, angstrom. But nano, a little bit bigger than angstrom. That is the changing point of the material to the atomic and the molecular level. So the nano, basically it's a matter. It's not a wave. So basically, this is where we are talking about, the nano. So the protein with DNA and size of the atoms, a little bit bigger. So they are angstrom level. So that is the nano. So that is scale factor. So when we are talking about the nano, so the definition of the nano, that is a 1 to 100 nanometer. As here, the nano size, that is the particle size, 1 to 100. 1 to 100 nanoparticle, if you have anything, 1 to 100, that is a nanomaterial, that is known as. That is the idea, that is the definition, technically and scientifically. So, when you have the nano materials, nano machines or nano fabricated things, then there are two ways to get nano. Maybe you have a bigger particle, huge rocks or something, then you crush them down, milling, grinding, further down to the nano level, from bigger particle to smaller particle. Or you can, that is the top down, and bottom up. Bottom up, you start from the solutions, atoms and the molecules, and you get precipitate, like in the pharmaceutical business. You make ascorbic acid, that is vitamin C. You precipitate up to that, but you have to have a control system to stop at nano level. Because the reason is, when you have the nano size, they are totally different. They are amazing particles. Not like bulk particles, not like atoms, not like molecules. To understand this scenario, it took many years. At the recent time, like 10 years, 15 years back, the scientists, they seriously understood the beautiful behavior of this nanoparticle, and they are amazing. They show magic, in other words. So how they show magic? Because they are totally different physical properties. Don't have the bulk material, big material, and they are totally different, showing chemical properties, and then electrical properties, mechanical properties, and optical properties. They totally behave totally different to that of the bulk material. So that's why, for example, the electrical properties, when devices are become smaller and smaller, having massive capacity, having multifunctional thing, and we can remember during our university, the life, we know that the mobile phone size is huge, like bricks, and we have to have a separate bag. Now it is becoming smaller. Mobile chips are smaller. Why? Because then you are now today everybody thinks carbon nanotube. You may have heard in the newspaper graphene, they are having amazing electrical properties. And also not only that, the chemical properties, physical properties, mechanical and optical. So those properties, we utilize those properties in our different products. When you have those materials in our product, that product can behave as magic. They show the same unexpected properties. So that is why they are using in the the application. In summary, like in information technology, the smaller, faster, more energy efficient, powerful computing, IT, that is the other side of the business. That is more engineering. And also here medicine, cancer treatment, bone treatment, drug delivery, appetite control, drug development, medical tool, diagnostic test and imaging, and even in the dentistry. So that's why we are using those things. What we are using nanoparticles in product, since they behave totally differently that of the bulk particle. But the challenging point is to how we get the nano. Why say nanotechnology? The nanotechnology, when you get the nanoparticle, then you have to have a technology to produce nanoparticle under control system. And with the existing technology, you incorporate, impregnate those particles into your product. That product behaves totally differently. So, and also consumer goods and energy, of course. That's the other side of the business again. So, and throughout the world, this is a hot topic. That is the emerging technology. So, and then the business size. Today, what is the business size? The economic impact of nanotechnology. Look at this graph. So that is Economic Forum by 2014, the business size is 3,000 billion US dollars. Nanotechnology business, all, including pharmaceutical, nanobiotechnology, nanomaterials, nanoelectronics, nano devices, nano machines, nano cancer therapeutic drugs, everything all together. That is a 3,000 billion business, nanotechnology. And then to have an understanding, this is our income as a country. So we have 67 billion. That is GDP in our country. So compared to that, this is a massive business. So that's why even the Sri Lanka is now interested, especially the Ministry of Science and Technology and the Technology and Research and National Science Foundation and all the ministerial, they are really seriously interested in nanotechnology and nanobiotechnology, because they think that if we get at least 2% of the business to our country, then we can double the GDP. 2% of the 3,000 is 60 billion, then we can double the GDP. So that is the idea. Okay, that's huge business throughout the world, and that is the basic idea of the nanotechnology. Right. So, but still, to do the nanotechnology, we don't need all the elements in the periodic table. This is pretty much familiar to all of us because we all did science. So therefore, no problem. So even though we have over 100 elements, we can do this 3,000 billion business with only few elements. That's it. What are those elements? Titanium, iron, copper, zinc, carbon, silicon, platinum, silver, gold, and sometimes helium. That's it. That is the business. So now we have to, so that maybe in pharmaceutical drugs, so you have magnetic nanoparticles, iron, nanoparticles. Whole pharmaceutical business is a massive business throughout the world, and maybe carbon. So anyway, these are few elements, only few elements. As a country, we have those resources. This is just to show you, to get an idea initially, natural resources in our country. So we have ilmenite, that is titanium bearing minerals, graphite, that is pure carbon from Pahatagaha and Bogle, graphite. We have the purest graphite in the world. And clay. So we have these three big huge resources in our country that are the resources to develop the nanotechnology, to develop the nanomaterials, and thereafter value-added product with the investor. So that is the idea, right? So the nano clay, this is the clay type. We call it nano clay because again the clay. If you get the clay, you know that the clay is a very good compound even for the drugs. You mix with drugs. Clay. Clay is not toxic. It's an excellent, the compound, excellent material to have the active ingredient with the clay. That is the idea. So, active ingredient with the clay, because you can have that active ingredient inside the clay platelet. So, therefore, this is clay. Clay is known as nano clay. That is because today I am taking only 3 examples to show you how it's important to us. Then, what are the health effects? Just to share with you some ideas. Right. So it's a clay because it's a nano material, it's a nano type, so you can get the pure clay in our country. So we have that material, and this is the application of nano clay. So nano clay basically, look at this. This is the highlighted in pharmaceutical industry, drug delivery carriers, and cosmetic industry. That is also important for us as the people who are in the health sector, cosmetic industry. And okay, they are like other side of the business. Electronic, that is engineers, textile, rubber, that is the other side of the business, clay. These are the most important here, and also food. We cannot forget it, food. Food poisoning, food, so that is important here, in this forum. Right. So therefore I am pretty much focusing this sector, and then Sri Lanka having a lot of clay, therefore no problem for us to move forward with the nanotechnology and to get the business to develop the country. That is the ultimate goal, right? Right, to like Malaysia, like other countries, developing countries. So we can do that, right? Okay, and then this is the scanning electron microscope analysis. That is the clay type, as I told you. So you can impregnate, you can incorporate some of the drugs into the clay, inside the clay, and using the different technology, using different mechanisms, using different machines, and then you can produce commercially available drugs, tablets or a capsule or whatever it is, with the clay. So therefore that is one part of the site where we can do the business with the nanotechnology, and also the graphite. Then move into the second source. Graphite, we are one of the purest graphite in the world, Karnataka and Google. So basically this is what happening in our country. We sell the 1 kilo $200, like $2. Now the dollar went up like 150 rupees. I think this is like 5 years back. So we sell all the graphite to Europe, especially to the German. The German, they have a massive company. They are doing a value-added product. They produce carbon nanotubes. They are totally different. They are amazing product. They produce graphene. They produce graphite oxide. There are many applications in industrial, pharmaceutical, health sector. We need it. And then, this is the price. The carbon nanotube, 1 gram, 150,000. 1 gram. But the problem is we have to have the technology. We have to have the know-how. We have to have the scientific ideas. We have to have the resources available. Maybe we have the people, expertise, we have scientists, engineers, and then plus, but we have to have the technology, and plus we have to have there are many factors, environmental factors, then finally political factors to get the investors. That is the other side of the business, right? Anyway, to get an idea, so therefore it's a value addition chain. So when you get the 1 gram, so that you know that in the health sector, some of the equipment are unbelievably expensive. So therefore, we need those materials, like having chips, mobile phone, high-end electronic devices, something like that. Right. To do that, we have to have that type of material, nanomaterial. And so this is the graphene layer. You know that we have heard in our A-level, the class that graphite is a layer structure. You have to take the graphene out. It's like a book. You have to take one plate out. So the guy did it in 2012 at Manchester, UK. So he won the Nobel Prize in chemistry. So he found the technique to get the graphene layer out, one single layer. When you get the single layer, that behaves amazingly. That behaves is fascinating. Then you can use, when you separate the layers and layers, then you get those layers into product. They are totally behave differently. Probably their current capacity is 1 million times higher. Their memory capacity is 1 million times higher. That is the nanotechnology. But we have to have the existing technology help to get the nanoparticle out. So that is the game. So this is just a to show a picture, and then we have different type of nano. When you get the plate, in thermodynamics, the more everything, when you know that the rolling is the most stable form. Even us, when we sleep, you are not sleeping like this. You roll. That's the most stable case. Thermodynamics is stable. When you get a mat, it's rolling into it. That is stable. So therefore, when you get the graphene layout, you roll, and then eventually this roll is a particle, is a material. You get one roll, that is single wall carbon nanotube. When you get two rolls, two plates roll, double wall carbon nanotube and multi-wall carbon nanotube. They can be used in different products. I will show you some examples. Right. So the properties of carbon nanotubes. Look at this. So they behave differently. So electronically, thermally, mechanically. Mechanically is very hard material. For example, so look at this. 45 gigapascal. That is the hardness. Steel, yakada 2 gigapascal. Carbon nanotube 20 times harder. So if you have the compound in dentistry with the carbon nanotube, that will be an amazing compound available in the market. So doctors can use it. I will show you. Sometimes you don't care about that because they come in the commercial name. So that is the idea. That is the betterment of the people living, betterment of the human being all the time. Science. That is why science develops every day. Right. So we use in that way. So we use all these properties. I'm going to describe all the properties deep. Like for electronics, say 1 terampere copper, 1 gigampere. Giga and tera 1000 times, 100 times, 1000 times bigger. That is why your mobile phone becomes smaller. Because you don't need huge material. In those days they use big material, bulk material. Now they are using nano type graphite. So that is why your products are very small. Right. So that's another part. And this is the application. Application again coming, different type of application. Again in energy, medical implant, drug delivery. That is the forum targeting here today. And then aerospace, other are like engineering, science, agriculture, other businesses. In medicine and health sector, this is what us talking today. This area. Right. So that is the application of CNT, carbon nanotube. And then this is a picture of the carbon nanotube application in satellites. Because they have huge memory capacity. They have amazing current density. They have amazing conductive properties. So therefore the hardness is very good, super. So therefore the satellite, aerospace, and then other side of the business. And then the third one, titanium. Because when you go to the periodic table, I told you there are few elements: carbon, titanium, gold, silver, copper, zinc, steel. Only 8 to 10, maximum 10. To do the business, 3000 billion in the world. And titanium, so the titanium, if you look at the titanium dioxide, nano titanium dioxide, they are massively used in paint and coating industry, pink industry, pharmaceutical industry, cosmetic and food. Cosmetic and food industry also going with health sector. Food poisoning, how it affects. So and also the cosmetic industry the same. Seriously, because it touches your skin and then hair and then pharmaceutical industry. So there are titanium dioxide, other materials, and then Sri Lanka ranked as the 9th biggest largest deposit in the world. 9th ranking out of 200 countries in the UN. So we are having the 9th biggest largest deposit in our country, especially in the northeast coast. So this is the picture I've been there some time back, 5 years ago, just after the war. This is 2011 actually. So I took the picture. That is the northeast coast. Northeast coast means from Jaffna to Batticolo. That is the northeast coast. So we have black sand which contain titanium and then other metal as well, like ilmenite, rutile, thorium. So the basically Lanka mineral sand they process and they send the raw sand to Japan still. Not doing any value action thing. They are not doing any value addition. Not producing titanium dioxide, not producing titanium metal. That's what we are need now. The country needs and that type of thing now. High technology and also to develop the country. So anyway, then this is value addition. The business side of the story. If you sell the ilmenite as it is, we can sell as the current price 1 metric ton $100. If you produce titanium dioxide, it's $5,000. If you produce nanotitanium dioxide, 50,000 metric tons. So basically, country earns today 20 million US dollars by selling just raw sand. But if you convert those raw sand into this titanium dioxide and nanotitanium dioxide, we could have earned 20 million. I said 20 million, 500 million is a net profit. But we have to have the other factors as I mentioned, the technology, know-how, investors. So that should come from the top-down method, not the bottom-up. In science, top-down means that should coming from the top. Okay, so we can raise the voice. Scientists, doctors, engineers, we are having the professional voices, but it should come from the top. That is called vision. That is the other side of the thing. That is visionary leadership in any business. Doesn't matter in professions or universities, businesses, visionary. Okay, right. So let's not talk about that. Anyway, so that is the idea now. And then this is the so basically how do you know that they are nano? Then you have to test it. You know that you can test. You get imaging. You do the X-ray diffraction technique, and if there is a fracture, you get the X-ray diffraction and X-ray. This is X-ray diffraction. Likewise, you get the spectroscopy and microscopic techniques. Spectroscopy and microscopic techniques, you have to have the materials and put the sample under the machine and then check. Get the imaging, very high resolution image. So that is how you know that nano. And this is what I did at Sri Lanka Institute of Nanotechnology. I worked there as a senior scientist and consultant 2009 to 2012 on secondment, being at the University of California, and that is the work there as a consultant. So they wanted my expertise to develop some projects. So this is some of our research team did. You look at this nano. So it's visualized. You can check. You exactly can produce some of the nanoparticle from the ilmenite, beach sand to nano to cosmetic. That is the value addition chain. Beach sand to nanoparticle, nano to pharmaceuticals. Pharmaceutical business, that is the way, right? So anyway, as I told you, the way if it is nano, it should need to be less than 100 nanometer. All the time, nanotechnology deals with 1 to 100 nanometer because they behave differently, totally differently compared to bulk material and compared to atoms and molecules. Bigger than atoms and molecules, smaller than bulk. That's the intermediate case, right? So and then with respect to the nanotitanium dioxide, so they have different activities, like photocatalytic activity. So if I tell you photocatalytic activity, what is the titanium dioxide? They can be used in nanopaints and coatings, sterilizing effects, deodorizing effects, air purifying effects, self-cleaning fabric, sunscreen product and cosmetics. Why? Because when you incorporate this nanoparticle, titanium dioxide nanoparticle. Now, for example, neutron, and you know that if you have the TiO2 in your cloth, so you impregnate into this my shirt. There are in the market there are shirts, so you don't need to wash. You can wear it because self-cleaning, no water. Why you are washing? You go today I am going and then just hang the shirt and tomorrow I can wear it. Odorless and odorless, retaining. So you can get that property through with the help of the nanotechnology, nanomaterials, and then with the existing technology. So that is the idea. So the air purifying effects, self-cleaning fabric, sunscreen and the cosmetic industry. That is the nanotechnology. And then if I go through the nano coating and nano paints, because now it's modern time, they are asking the nano paints because they have properties like hydrophobic, not hydrophilic. Hydrophobic, we all know that doesn't like water. not water retaining. So hydrophobic. So you paint something. You paint your car. You paint your wall. You paint sky-high buildings. Once, that's it. Once for the life. There is a nano paint which is hydrophobic. So no dirt on it, no fungi, nothing. Every day it's look elegant. So that is, and then these are the properties. So excellent corrosion protection, no corroding, because that superior property coming with the nanoparticle, with the nanotitanium dioxide, and then excellent addition, excellent coverage. So those are the fog-free surface, antibacterial, anti-ice, auto-cleaning properties. You have everything, 1000 in one, not 2 in one, because of the nanotechnology. So there are products in the market now. Apparently it's little bit expensive. You know that when the new product comes into the market, brand new, is going to be expensive. And with the time, with the space, they are become cheaper and cheaper. You know that how expensive television in 20 years back. Now it's, like even I have the same television, like we spend like 50,000 rupees to get a 20-inch or a massive television. Yeah. So now the LED cutting very thin, fine, like so that is the case. So therefore that is the business side, and then let us move into the sunscreen cream and the cosmetics. So this is pretty much interesting with the titanium dioxide. Titanium dioxide is one of the major raw materials in the cosmetic industry, and also the sunscreen cream. Especially cosmetic, when you come to the cosmetic, there are different types of cosmetic: lipstick, cutex, foundation cream, hair dye, everything. Okay, right. So basically, why the sunscreen cream? You know that to prevent from the burn. So the sunscreen cream are applied even though it's not common in our country. It is common in our country when the Sangakkara and Mahajavan playing cricket, they are applying sunscreen cream on their faces. Okay, so because unless otherwise they can't play a test match, they end up with the skin cancer. So you have to protect your test playing people. So not like us. So therefore sunscreen cream, especially in the European countries and the other countries, very famous. We compared to other countries, we are very tiny little country, 21 million population. Compared to like the United States, over 350 million people. So that is why business is such. Right. Anyway, so to sunscreen cream and cosmetics are applied for two purposes. Number one, as a decorative paint or coating. Number two, as to protect. You know that. So the decorative means the cosmetics are sometimes decorative or protect. Both. So there are two purposes. And then, so basically, this is the science. So UV rays coming from the sun. So some of the UV blocked by the ozone layer, but still UVB and UVA coming to the Earth's surface, and then when they interact with our skin cancer, cataract, sunburn, and these are the things that can happen. So therefore we have to seriously look at those cases, especially when you are in the sun longer time. Okay, and also that is why the cosmetic and sunscreens are there. And then this is a scientific thing. We all know that if you expose your skin longer time directly to the sun, UVB coming to the earth, they interact with the DNA, and then there is a timing bond, additional bond can form. So the direct damage of DNA by timing creating bonds between nitrogen bases. That is unwanted thing, additional bond making. That is a tumor. So that is the skin cancer, basically. Additional bond making, not a natural thing. So that is the issue. So that is the simple science, if I explain scientifically. And then sunscreen cream and cosmetic chemistry, basically those are the ingredients: zinc oxide, titanium dioxide. So this is the UV range. So protect, they absorb, they block this range. This is the UV range. There's a range. Like X-ray, you have a range, frequency and the wavelength. So they block. And previously, like 30 years ago, 50 years ago, before the Second World War, so all the pharmaceutical manufacturers, they always use organic compound like para-amino-benzoic acid. That they are also doing the same thing, but the problem is they can damage our skin as well. Not like this. These are inorganic. Inorganic materials are harmless. Organic materials anyhow harmful. Volatile organic compounds. We know that. Now, it's not good. They can damage our cells. They can, if you go penetrate into your system, they damage things. Therefore, nowadays, so they avoid having these ingredients in their cosmetic and sunscreen cream to get the certifications like SLS, ISO, and there are other 14,000, 21,000, and then so on. So to do that, so you know that some different, now for example, in Sri Lanka with some of the big giants, mainly cosmetic and sunscreen cream, nature secret. I am not going to say who are good people, just mention, and L'Oreal. So if you can look at, get the bottle and then what is the certificates. And then that, because then you have to stick to the seriously, according to the recommendation given by the WHO, World Health Organization, and EPA, United States, Environmental Protection Agency, United States. So that's how they produce those pharmaceutical products. And then the beautiful story of the nano and the micro, when you get the nano particle, as I told you, they behave totally differently, but they do the job. Now here, look at this here. This is a nano TiO2 1 to 100 UV block. UV rays coming. Now I apply the sunscreen cream or cosmetic block. Visible light, transparent. Visible light, transparent, visible light going through the particles. But if you get the micron, bigger particle size sunscreen cream, UV block scatter, visible light scattering. In other words, in simple, this is easy to understand. So I got this picture from the journal, International Journal of Chemical Engineering News, August 2011. This is the volume. Published, top class journal, high impact journal, and sunscreen cream with nanomaterial. This say husband and wife. So basically, ladies, they always want to have this. They want to show that even though you apply the cosmetic, as if you haven't applied anything. That's a natural beauty. That's marketing. That is a trend today. So, but the men's, they don't care. Now, we don't care. Some are having white faces on the bed. We care about the centuries. So that's the marketing and the business. So therefore, accordingly, you have to have the product in the market. Because the cosmetic and pharmaceutical business is a massive business throughout the world. That is why 3,000 billion compared to our economy. Our income to the country 67 billion, including your salary, my salary, and the presidents of the country salary. So that is why this is the case. This is the technology side. So sunscreen cream with micron size, bigger particle, it look white. Sunscreen cream with nanoparticle doesn't look white. Even nobody can see that you haven't applied anything. They think that you haven't applied anything, but you blocked everything, you are protected. So that is one of the examples. This is the cosmetic business. Electronic business, other side of the thing. Right. So, and then self-cleaning fabric. Self-cleaning fabric, again, nanotitanium dioxide, they impregnate, they incorporate the nanotitanium, because nano now is very tiny particles, it's like a mercury atom. You can't see by your naked eye. So therefore, they incorporate, they impregnate the nanotitanium dioxide into the yarn or fabric. Then they incorporate. Then they self-cleaning, eventually they become self-cleaning fabric. Odorless. Antimicrobial properties. So therefore, they are very useful. Where they are useful? They are useful not for the day-to-day like us. Very useful in hospitals, especially in the developed countries like United States, Canada, and Europe, especially Germany. They are seriously concerned about the nano-impregnated materials, cosmetics, and fabric, especially for the hospital bed sheets, hospital curtains. Antifungal, antimicrobial, odorless, and also military people, because you can't wash the cloth in the middle of the war. You have to wear probably weeks or months. Then, so these are very important materials. And so there are materials in the market. Marks and Spencer, the giant in Europe, self-cleaning fabric like socks, and Victoria's Secret, that is in United States, especially in America, North America. So they are having self-cleaning fabric. There is a huge market in that is a business side of the nanomaterial. Now I talk about the titanium dioxide, carbon and clay. There are many applications both in the industrial, domestic, health sector. So that is the application 1 to 100 nano. You have to get the particle, production of the particle with the existing technology, that is the nanotechnology. When you have the nano, because they are showing amazing properties. And now this is the topic today, the nanotechnology dentistry. Now let us have a look. Right. So the bone regeneration. You know better than I do, of course. This so dental implants, disease prevention. Now mouthwash. Mouthwash, you know that the commercial level mouthwash. What is the purpose of having a mouthwash? To prevent from the bacteria. So look at this. Look at this. Silver nanoparticle for prevention, biomimic. So basically silver nanoparticles, they prevent from the coming, that is the antimicrobial activities. Like this, for example, say bone regeneration, nanocrystals of calcium sulfate, you refill because they are harder. You can have your artificial tooth, say 25 years or lifetime guarantee. So they are product in there. And then tissue generation, like they all are nano. So they are in the commercial silver nano nitrate. See, so I told you silver, gold, very few playing in the business. So this is diagnostic. Quantum dots, that is pretty much more highly scientific thing. I am not going into that one. So you have different type of machines using the nanotechnology. So the drug delivery system, tissue generation. So those are, for example, these compounds: calcium phosphate, zinc oxide, antibacterial. So the nanoceramic composite material in dentistry. See, calcium sulfate plus zinc oxide nanoparticle with carbon nanotube provide flexible and inert scaffold. Not like bulk particle. So that is amazing. That is amazing. That is in the health sector directly applied. So that is in the dentistry. So therefore, today, us not producing anything in our country, as a country, we don't have any, at least we as of today, we don't have, basically any country's development measured by, there are many parameters and factors. Number of chemical factories, us not having a single. Still, we had Palantan, we lost it, that's it. We are not producing sulfuric acid plant. We don't have a nitric acid plant. Basic acids even. Nitric, that is oleochemistry. Oleochemistry, sulfuric, nitric, hydrochloric. We are not producing sodium hydroxide, calcium carbonate, even LUNU, yes. Calcium, luckily we are having at least sodium chloride, that's it. If you have the sodium chloride, why not sodium carbonate? Why not caustic soda? Why not other things? We have it. Still we are not having that. So therefore we are not producing any commercially available commercial product to supply, to export, even to produce in our country. So but still we have to have idea. I know that this is we know that in the country, us like the university graduates and the professionals, basically all people is called critical mass of the country is 30% in our country. That is a problem. If it goes to over 50, then it's not a joke. Then nobody can lie when we come to power. So so that is critical mass need to go up. Higher. Like US, Canada, they are critical mass like 70. Then 30% they are not deciding who is the leader. Now is that other way around. Right? Okay. So that's the dentistry, and then now the health effects. Now I am going to finish very quickly in 5 minutes time, and then the nanoparticle, health, effect and toxicity. Now this is the globally harmonized system. So basically classified in labeling of the chemicals. You know that in any chemical, any bottle, if you have this symbol, this is a world accepted one. So it's a flammable. It's a flammable. And then corrosive. If it's corrosive, that is corrosive. You can't eat it. That's it. Okay? There's no question. And explosive is explosive. Right. And then compressed gas, oxidizing, toxic. Toxic means you don't need to test it. That's it. Toxic. So, and also here, health hazard, harmful and irritant and dangerous for the environment. So, for example, so now I know that chlorine gas. Chlorine, say for example, chlorine gas, if you have a gas tank, it has this symbol. Dangerous for the environment. Therefore, you can't dump into the river if it's expired. You kill all the fish in the river. I know that there are cases in our industries. I don't want to quote it, but some industries they are getting the chlorine gas. It's expired, but expired means 100% not chlorine. It has 80%. It is not good enough for their manufacturing process. But then what they have, immediately because that the whole fish, you know, that is the issue. So therefore, any particle, anything, any compound, acid, base. So if you have these symbols, that is known as toxic and that is healthy. In simply, there are 9 pictures. Right. If the petroleum, yes. Say for example, petrol. This is the symbol. This is the symbol, and the petrol has this one also, harmful. They are not saying toxic. If you have 1 drop of petrol, you never die. Okay, right. So therefore, this is a globally harmonized system. That is about the nano. Let us move to nanoparticle. And also we have a chemical abstract services CAS number, but the unhappily still there is no exact CAS. CAS means chemical abstract service number according to this GHS. This is a well accepted globally practiced notation. And nanoparticle, we don't have, there is no CAS number for the nanoparticle, rather it is for their bulk materials still they don't have. Nano bulk, they behave differently, but toxic level, health effect, still the scientists, they haven't documented, they haven't regulated. So they are saying we are toxic and then so on. Still we don't have anything. For example, if it is titanium dioxide, bulk and nano, the same. That is what they are saying. Same. So if you eat potassium cyanide, 1 gram bulk, still you will die. Potassium cyanide, nano 1 gram, still you will die. That is what they are saying. Okay, but there are effects. Still they are, you know, they are doing research. Still they haven't come to a very solid rock conclusions. That is the issue, right? So, and then regarding the nanomaterial, the biggest problem, they can penetrate into your system, going through the, you know, the nose, mouth, and then so on. And then, so they can create neurological diseases and asthma, and these are the diseases. That is the issue. But to monitor, to come to a solid conclusions, you have to have a way, you have to have a real procedure. So that is the case. So therefore, nano disease, so it is said that diseases associated to nanoparticle exposure, these are the diseases expected. And also on the other hand, so if you look at the nano TiO to nano zinc oxide, these are the questions need to be asked. Easily activated, no penetration through the skin, question mark. Is it penetrating? When you apply sunscreen or cosmetic having nanoparticle, or if you wash your mouth with a mouthwash having a silver nanoparticle penetrating, other than going through the digestion system, into the depositing in the liver, depositing in somewhere, those are the questions need to be asked. And then not damaging the skin, or not a carcinogenic material, no genetic toxicity, not affecting the reproductive system. Those are the things that need to be questioned. Still not known. That is the issue. But if you are talking about the energy, no problem. You develop energy. You develop a mobile phone. Issue is especially in the cosmetic, pharmaceutical and food and beverage industry. That is the issue. That is in dilemma. That is a questionable still for the scientists. And then, so the people did some research, couple of research articles, and then this is the one of the sunscreen formulated with zinc oxide. They formulated sunscreen cream with zinc oxide and nano zinc oxide. Zinc oxide blocked the UV rays, and then they did the research. So basically, they selected group of people, 23, and then 2 applications per day, 5 consecutive days, asked these people to be in the sun. They were paid like $100 per day. You can be done in the USA. This is happened. So this is done where? It's done. This is the research team by the Sydney University in Australia. So this is the toxicological sciences published in 2010 by the research team Sydney University in Australia. So this is a top class article, and then thereafter what they did, they collected the blood sample and urine sample before applying administration, and then after, and couple of days after, and they check whether you have the high level of zinc oxide in your bloods or in your urine sample. Yes, they found. That is the issue. They found. So that is means nanoparticle can penetrate, because you know that from through your skin they can penetrate. So but still, in that paper itself, it's a top class journal, high impact journal. So the red line are for female subjected administration nano sunscreen cream, but still they concluded this way. See, for zinc oxide particle in sunscreen can penetrate. They are not saying still. And layers of the skin exposed to the sun in a real life environment can be detected in blood and urine. But they haven't said anything thereafter. It's done by the Department of Health Sciences. We know that there are some departments like that in those universities. So that is one of the research, and other research. Other research they did the same thing for sunscreen formulated with nano TiO2. Now this is one of the biggest key raw material in the cosmetic product, and also dentistry as well. So they did the same thing, titanium analysis done. So that is this research team in National Cancer Institute of Maryland in USA, United States of America, done toxicological sciences published in 2010. And again what they did, they applied the sunscreen cream with nanoparticle, they applied sunscreen cream with bulk particle, and get the body parts of not the people, of the pigs. Pigs are there. Because you know that dermatologically pig skin and the human skins are a little bit more or less similar. So that's the testing. So and then what they did, so the pigs has known to be the best model for the human skin, and application of the sunscreen cream formula at 2 mg. This is the way application, 4 applications per day, 5 days, week, 4 weeks. You don't need to pay money for pigs, even to be in the sun. And these are the research. So that you get the mini pigs basically, young guys, right? So and then you get the skin. They are not saying anything, liver, kidney, and then you analyze. You get the 100 pigs and they analyze, remove and detected, they digest and the sampling, and then thereafter detect titanium using ICP-MS, and then finally they found that this is the day. The level of titanium increase. That means they conclude that they can deposit in your some part of the bodies. If pigs, why not in human being? Problem is you can get 100 human and you can't do this analysis. That is the issue. That is known as clinical testing. You doctors know better than I do. I am a scientist, so basically I did chemistry and then chemical engineering and then biochemical engineering and then nanotechnology and environmental sciences throughout my 18 years of my career. So in US and UK and Sri Lanka, 5 years UK, 5 years USA, and then here. So that is what, and then the level of titanium in liver from mini pig treated with sunscreen cream increased. Liver. So so they found it, they reported, they published, and then this is toxicological analysis, and then the level of titanium in epidermis isolated skin taken from the mini pig treated with sunscreen, again they detected. they detected more than they expected. That is the issue. Toxicology sciences. And then level of titanium in dermis isolated from the again is increased. And then, but they conclude that indirect damage caused by the hydroxyl radical by sunburn and then formation of superhydroxide is a check and balance now. What they are saying, you can apply sunscreen cream or a cosmetics or a new available product, mouthwash, according to the prescription prescribed by a qualified doctor. That is why you are there. Not as you want. If you apply 5 times lipstick every day, it can damage them. When you go for a wedding, you apply. Function, apply. That is what they are saying in other words. So that is, and plus you have to concern, as educated people, we know that we are concerned, when you get a good product, we are not buying product, cosmetic from the second prostitute. If you can add second prostitute, they will also be done. We get a branded and good quality product. So that is the issue. So we are with that note. So I want to thank especially my 2 bosses. They seriously helped me throughout my life. Still, I am doing research with them. Professor Rosen in England, and also my PhD boss. And after that, I worked with him. And thereafter, I have been as a visiting professor to the US for 5 years and worked with Professor Michel. They are amazing, nice people. And also, I want to thank Sri Lanka Institute of Nanotechnology, Ministry of Science and Technology, and also Department of Chemistry, where I work since 2000 as a senior lecturer. And also Sri Lanka Dental Association, giving me chance to share my knowledge. Thank you very much. So, thank you.